Hi there, RStudio friends. Welcome back to my YouTube mini-series, which at this point is kind of just a series regarding a lot of important things that people do in R. And firstly, Merry Christmas, or Happy Holidays, and Happy New Year to you guys. I hope you've had a good one, and I hope that 2026 will bring you everything that you want. So I think that today what we'll do is look more at models, linear models specifically. Whenever people learn modeling, they always start with linear models, straight line models, which we looked at prior to Christmas. And what we did in the last session, okay, where we made a straight line model, we used the Gala dataframe. Gala is information or data on animals that live in the Galapagos Islands. And we produced a model, well, we produced a couple of models, straight line models, which firstly were interested in every single column besides the response column as being predictors. So the response column in that data frame was species, and then you can do squiggly line dot to include all the other columns if you think that there's a reason to include all those columns in your model. And then that's looking at how those predictor columns affect the number of species. And then we made another model which was not interested in all possible predictors, but only one, which is area. So seeing how the area of an island in the Galapagos Islands affects the number of species on the island. After that, we looked at the summary code. So summary of any model, with the model name being in brackets, gives you information which can tell you if there's a significant effect of a predictor or predictors on the response. So did area significantly affect species? And remember that for absolute beginners, the word significance in statistics and in science is different than the layperson's use of the word significant. Okay, significance really refers to p-values and refers to this 5% or less chance of having an error or the same result occurring due to random chance. Okay, whereas like in the newspapers or whatever, significant generally means considerable in layperson's terms. And then we just went on to make a graph of that, you know, but the important thing is that we got p-value, and we got an estimate, and we also got the estimate for area and estimate for the intercept line. Those two estimates go into the equation to produce this equation. So what I would say is that the number of species, y, equals 0.08196 multiplied by the area plus 63.78286. And I hope all of that was clear. Let me know in the comments below if you'd like to revisit the summary code, because that's the first step when it comes to checking the results of a model. However, we didn't really know if it was a good model or not, and that's why you need to look at residuals, and you need to also check metrics for goodness of fit, like R-squareds and AIC. And we'll do a little bit of that today. So the next thing I'm going to say is we're going to work with a different data set in the faraway library. Okay, the faraway library contains all of these hundreds of data sets, data frames, and I like this, you know, because they're all on totally different subjects. Look, view pulp, okay, brightness of paper pulp depending on shift operator. Diabetes survey on Pima Indians. Hair and eye color. Percentage of body fat and body measurements. So this is a kind of script that I put together, you know, with information about every single one of these. I probably got the information about each data frame from the internet. I don't know personally the developer of this library. If this was all one person working on every single one of these subjects, that's incredible. but it's probably more a compilation of different data sets that were the projects of different people. Okay, now remember that if you are to play around with these libraries or work with them, you have to have the faraway library loaded. Use the library code for that. Or, as you remember, in RStudio you can turn it on in the packages, like where these boxes are. There'll be a tick when it's turned on. A lot of the libraries are not turned on by default, like I said before. Okay, the one that I think we can look at today is called teenage gambling. And I just thought this sounded interesting, okay? Study of teenage gambling in Britain. And we know there's a lot of problems with that and with other addictions in Britain. And so this is a data frame that has 5 columns and 47 rows, 47 entries. You can either use the dim function to check the number of rows, or you can just check the number here in the grey area at below the data. I don't really know too much about this data frame, okay, and I deliberately try not to work on this before the session, and that means that we can kind of learn together, and I can really show the real emotions and the real discoveries as I go through, you know, so you'll see how the kind of process of data analysis works, rather than being corrupted or interfered by any bias, you know, that I might have about the data or about the subject in the first place. So firstly, I would go into Google and I'd see if we can get any more information about this data frame. The column headings in RStudio are only partly useful. I mean, the sex is obviously 1 or 0, so that's probably, you know, binary, male or female. We'd need more information about which one was which. That information is not provided. Status, from this we'd have no idea what status meant. Okay, so we'd have no idea what these numbers meant. Income is obviously some sort of monetary income that people are getting. Verbal seems to be some measurement of, or some code for how good their verbal skills are. Which is maybe related to education in some way. And then gamble would be the response column, okay? Again, it's not clear from this what the units are for the gamble column, but it's obviously some measurement of how much they're gambling or their gambling risk. So we need more information for sure. Let's go back to Google and search for the name of the data frame and the word faraway. And this is it, okay? Study of teenage gambling in Britain. Okay, 0 equals male, 1 equals female. That's answered one of the issues. Status is socioeconomic status score based on parents' occupation. Helps a little bit more, not entirely. We would have to know what the actual numbers meant. Income, we found out now that this is income in pounds per week, so we have the units, and that's really important. And you know what, maybe I will make a copy of teengamb, call it teengamb 2, and rename some of these columns with the new information that we gained here. Verbal, yep, verbal score in words out of 12 correctly defined. Obviously the developers of this project or data frame are using this as a measure of intellect, maybe education. And gamble is expenditure on gambling in pounds per year. That's really important. This would, for this purpose, we would be using this column as the response. And the model would be designed to check how these other columns are affecting this column. These other columns, sex, status, income, and verbal, could be possible predictors. Maybe not all of them will be, but we can use the summary codes and some other techniques I'm going to show you today to check which ones are. Tell you what, let's just copy and paste this and put this into our script. So I'm starting a fresh script. I'm going to leave a hashtag. Let me move this here. And this is crucial information because without it we wouldn't know the units. And I have this issue a lot when I look at data frames online, especially, or that are parts of libraries. You won't be able to tell necessarily what the units are unless you check, and the units are crucial, absolutely crucial. Obviously, income in pounds per week, you know, the fact that it's pounds is very, very important to know, and the fact that it's per week is very important to know. So let's do make a copy of teengamb and add this information to the headers. Okay, and prior to doing that, let's set up our libraries that we would be using in this session. And we'll see how far we get with this, because obviously you could spend hours and hours on different modeling stuff, tips and tricks, but this is a very good start that we're doing today. So firstly, find out what your units are. First tip, first trick. We're going to use a couple of libraries here, so obviously this needs to be outside of hashtags. Let's do CA tools. Okay, I use this one for splitting data into testing and training data sets. And don't worry, that might not make much sense at the moment, but it will when we're about to make a model. Data frames. And that might be enough for now. And of course, faraway. I've got this one loaded already, but you'd have to have this loaded. This is where our teengamb dataset is found. I often just don't write anything next to tidyverse because we know what it's for. It's for cleaning, it's for plotting, it's for other stuff as well. So I have that running every single time, and I always have these running at the top of the script. View teengamb. Okay, so let's do a teengamb 2 is based on teengamb. Pipe function. Okay, and then we're just gonna do a couple of renames here where we can edit the column titles to make a bit more sense. One option is that we so you always have to put the new name of the column equals the old name of the column. So we could say something like this: sex dot 0m.1f equals the old name of that column. Yeah. That's important. Spelling. R is incredibly inflexible to spelling things wrong, even although it's obvious we're referring to the same column. Before we do any more changes, let's just check to see that's worked. Yeah, it has. So now we've got that extra information about what the zeros and ones mean in this column. It is interesting that there's no other numbers in there, for example, other or non-binaries. But that's what it is. So status. Status is a score. I'm not sure what this is, but I'm not going to spend too much time on it. We could just rename that to social status. Okay, let's just add it in here then. Socio status. Again, always the new name of the column equals the old name of the column, and you always put both the old name and the new name in quotation marks. Okay, that worked. I won't bother checking it yet. Back to the teengamb 2. Income is in pounds per week. Income, pounds, and you notice that I'm putting dots instead of spaces, and you'll remember the reason for that is so that we can plot these column titles columns more easily using ggplot. We can refer to those columns more easily in ggplot compared to if there's spaces. ggplot does not like spaces. Okay, that's that one taken care of. Verbal is verbal score, okay? Again, with 8 probably being the best verbal score. I'll put verbal score. You don't need to change the column titles here. We could have them, for example, changed within a graph, only at later stage and not here, but I like to put the units in as early as possible so that I can keep track of what's going on, especially for a response column like this one, the gamble column. And this is gambling expense, let's say PPW, pounds per week. That's the new name of the column. You go to after the closed quotation mark and you put the old name of the column. Perfect. So some useful reminders here are get into the habit of checking not only what your units are, check also the data types. str teengamb2, and we'll work with teengamb2 from now on. They're all int or num, so integers or decimals. Remember, num equals decimals. So we can leave a note there, all int or num, and you can kind of see that as like they're all numbers, which is great because it allows us to do a couple of things. Firstly, make a pairs plot. And this is really getting into the data exploration stage. We do this so that we can see already if there's any obvious relationships between the gambling expense PPW column, the response column, and those other columns which are possible predictors. The model will be potentially informed by that knowledge. So let's see, pairs, simple pairs plot. Because all the columns are numbers, we can just put the name of the data frame in and it will work. teengamb2. Alright. Remember that it's a mirror image on both sides of the words right now by default. So if you put upper panel equals null, gets rid of the mirror, and you just have the one batch of information down here. Alright, I don't really like using pairs when it's comparing a column that's only got like binary numbers, 0 and 1, with another column, because you get stuff like this and it doesn't really look great. However, okay, so these are the individual points. It does look like the zeros, you know, because, okay, look here, 6, in this case the zeros are the males and the females are the ones. So you're going to pair this up, look in the corner here. This corner plot is a relationship between gambling expense and 6. Since the numbers are higher here at the 0 on the X, that means that you've got these males seem to reach these higher levels of gambling expense compared to females, which are right down in the corner, and these are the ones. So there's obviously something going on there, huh? Guys, lads. What else do we have here? Oh, this looks very interesting. This is, okay. Remember, you're mostly interested in this box here, so we're going to pair this over. We've already done this one here. Let's go here. Socioeconomic status. Kind of looks maybe as the score goes up. That's on the x-axis, the socio-status score. Just like the sex is on the x-axis here, the score is on the x-axis here. As that goes up, the gambling expense pounds per week might go down. Okay, in general. We don't know whether that's statistically significant or not yet. Income pounds per week. As income pounds per week goes up, the gambling expense seems to go up, according to the graph. Verbal score, maybe not as clear. Okay, I mean, in terms of this though, that kind of makes sense because as you're making more money, you can potentially spend more of it on recreational activities, including gambling. There's stuff in this data frame that I think is obviously important, but there's also stuff that is potentially missing. If I was to do a project like this, I would probably want some sort of measure of risk taking in people. I helped someone on a project about that, and what I would expect is that, you know, as you're more prone to take risks, you're going to spend more on gambling. So that information is not here. But this already gives us some information. Now let's make a model, make a linear model that includes with gambling expense PPW as response, and the following as predictors. So that's going to be sex, it's going to be social status, it's going to be income, pounds per week, it's going to be verbal score. So that means we've got 5 potential predictors here. What I'll do first is I'll make the model on the entire data frame, and then I'm going to show you a little trick about splitting the data frame so that we can just use some of it for training and the other for testing. That's the proper way to do it, because if you ever make your own models, what the ultimate goal is to predict stuff. It's to, you know, if somebody was to give you more information or new rows, that you would be able to apply a model you've already made from the training data to the testing data, to the new data. But we'll do it on the entire data frame first, okay? And so you remember that we call it a name. We'll just call it full model. Back arrow LM data equals teengamb 2, and then it's y squiggly line x, y being the response, which is gambling expense dot ppw. This is where also it helps to have the dots instead of spaces. It wouldn't like it if we had spaces here. Squiggly line dot, that includes everything. Remember, before we even try to run that, we're going to do options scipen equals 999. And if you remember from last time, what that's going to do is it's going to give us our p-values, which are a crucial part of determining significance. It's going to give us them in decimals, and that allows us to compare easily with the alpha of 0.05, which I talked about in the last session. Otherwise it will be exponential function. That doesn't really help us straight away. So we do that first, and then we just do summary of the model. Summary full model. Alright, so what do we have here? Move this out of the way. At some point I might end up using different video software where I don't need to constantly move the little video of myself. But I hope this works for now anyway. We're working within our means. I copied and pasted this over. And we have these column names given here. And I won't bother making a I'll take this out for now. I won't bother making a regression equation. We're not going to talk too much about that now. We're going to use other ways to check the goodness of fit. Like leave the model equation stuff for last time. I might come back to it in the future. You're going to need to obviously hashtag these out because they are not code. And then we'll just focus on the things that we need from this. And so the estimate would be used to make the regression equation, the estimate column. These are your p-values here. Okay, so we've got 2 columns with stars next to them. And having stars next to them, that means that those values are less than 0.05. That's a significant effect. So what I can do is I can just copy and paste the 2 lines that are significant, and we'll focus more on those. Okay, so sex is significant. Income pounds per week is significant. These seem to be the 2 most important predictors in the model. The rest potentially could get deleted. This is where we will mention a little bit about r squared, and I'm going to take this out for now. Okay. So for the full model, your adjusted r squared is 0.4816. Okay, and what that means is that this means that the model actually describes 48.16% change in the gambling expense PPW. So R squared is on a scale between 0 and 1. Closest to 1 is closer to 1 is better, closer to 0 is worse. And if it's 1, that's 100%. Okay. So 48% is really pretty good, I think, for anything in behavior, to be honest with you. But that's including everything, and it turns out that some of it isn't important, so those can get taken out anyway. Okay, so we will just make a new model that only includes those significant predictors, and we're just going to do it manually. Instead of automatically, there are other ways to do it, other libraries to use where you just remake the model. You can use the step function as well. That's just only going to give you the best model possible. There's also something in OLS or R library called OLS underscore step underscore all underscore possible. And that does the same thing, but we just make it from scratch at the moment, okay? So, edited model is, I'll call it edited model, why not? Back arrow LM data equals teengamb 2. The response, what we can do is we could just copy the parts we need from this. The thing that's going to be different is there's not going to be a dot anymore at the end, because now we're going to put these two columns that are significant, and I would just copy and paste their names. And then we can check the R squared again, and that's one of the things you can do to check how good the model is. I don't know if you can see this, guys, but I've got this little box that like starts and stops recording, and it keeps getting in the way. I will definitely get better software in the future, but let me know if you have any suggestions for good software to use, hopefully not too expensive. Okay, so that's the new model set up. Okay, so this is now going to run summary edited model, and we'll get some output again. Okay, now these two are both significant as we saw before, and you have an adjusted R squared of 0.4787. Note that there's also a multiple R squared shown there, but most people use the adjusted one. Multiple R squared can go up the more predictors you have, the more columns you include. Adjusted doesn't seem to do that. So most people use adjusted. It's more precise. So it's very similar actually to the previous one where we included these other columns too, and that shows you that the other columns are really not making much of a difference anyway. Okay, so what I can do is I can put this here, and we'll just call this our final model for now. Final model describes 47.87%. Describes 47.87% change in the gambling expense PPW. We talked about R squared there, but an additional metric, okay, for checking how accurately or how well the model fits the data, goodness of fit, is called the AIC. And AIC is, let's see, it's got a strange name. It's something like a KK information criterion. Is an estimator of prediction error and thereby relative quality of statistical models for a given set of data. AIC deals the trade-off between the goodness of fit of the model and the simplicity of the model. What you're looking for here then is not higher numbers like we saw in the R squared, but lower numbers. So lower AIC is better. And so what we can do is we can check the AICs of the two models that we made, the full model and the edited model. And this would be extra information that you can provide to say that why you chose the model you did, or why you made the model you did. It's small letters for AIC, and we'll just run them both together, why not, and see what the numbers are. Okay, maybe it's not guys, maybe it's capitals. In another library it's small, but I don't have that library loaded. So capitals is base R. Great, so you notice that the R squared was better for the edited model, and the AIC is slightly better too, because it's slightly lower than the full model, just. But it goes to show you that the other columns were not needed. And that's important knowledge as well, because if somebody is wanting to continue working on this subject, then they might consider that the columns that were excluded, from our edited model, for example, this one here, the socioeconomic status and the verbal score, might not need to be focused on as much. Maybe saving some time for the researcher and allowing them to focus on other things that are important, such as risk management strategies and risk aversion. Now that we've talked about R squared and AIC, the next thing to do is a quick look at the residuals, and then I'll finish by showing you how to split the data so that you can run the model on new data. Okay, so the residuals are your difference between the observations and the predictions. And this is very important because this needs to be checked to see if any assumptions of linear models are being violated. And we talked a little bit about that last time with the link from the, I think it was Virginia University, that showed what good and bad plots would look like in terms of residuals. We're just going to do a plot of the edited model. But first we are going to put par mf row equals c2, 2, and that's going to show us all 4 plots on the same page, because there's 4 of them. Okay, that message comes up all the time saying the margins are too large or small. So I won't spend too much time on this, but you'll remember, firstly, QQ residuals, it's always the first one I go to. You want all your residuals, the differences between the observation and predictions, to fall onto this diagonal line. When they don't, you might have a problem, okay? Meaning that it might not be suitable to do the kind of model that we did. We have violation here with 36 and 24 and 39, but that's actually pretty good, to be honest with you. And if these were taken out, we'd have pretty good fit there. Red lines, they should be flat. They should be horizontal. So maybe since we see this kind of pattern going on here, and here, shaping the data, we might have violation of equal variances, the equal variances rule. So we've got to check that. And there's things you can do like transformations, like I talked about last time. So we won't spend too much more time on that. That's just a quick reminder of the residuals and the importance of checking them. You would definitely want to check this prior to saying for sure that linear modeling was the right way to go. But it's okay to run the linear model first and check this after. It's more just about whether you present that as your final solution or not. There are alternatives. Even if we continue to use linear modeling, we could do transformations or delete these outliers. Okay, great. So we've checked briefly the residuals, and we'll come back to that in the future, don't worry about that. As I said before, we generally try to split the data and make the model on a certain proportion of the data, normally about 60%, a proportion of 0.6, or 70%, a proportion of 0.7. That then leaves the rest of the data in the data frame, in the original data frame, for actually predictions, for predicting the teenage gambling expense, PPW, from the contents of our model, from the model. So that's the main way that people model, is because, you know, they wouldn't they would typically be applying a model to new data that comes in. You know, they wouldn't really make a model unless it had some sort of predictive capacity. So let's check this now. We're going to use CA-Tools library, and we can do don't worry about this stuff here. This is extra stuff I thought we might talk about, but we'll save that for later. It's about checking normality and shape of distributions. Let's make a training rows logical vector. And then it's going to be this one here, sample split CA-Tools. So what we want to do is we want to sample split the number of rows in the teengamb 2, comma, split ratio. This is what we want here. So we want sample.split before the bracket and split ratio in the bracket. 0.7 is what we'll go with. 70% of the data is going to be assigned to the split, to the training rows. Okay, so that's the first part done. That's created a logical vector for what we're about to do next, which is actually create the split data frames. Okay, so training data, subset, back arrow of subset, teengamb 2 again. That's your data here, the original data. Training rows, so that vector equals true. That meant that, so what we've done there is we have created a data frame with 70% of the rows included, and this is going to be training our model. You probably figure out what we do next then. The testing data set would basically be everything that's not that. Equals false. Change this to testing. Okay, quick check of the number of rows in both of these should tell us if our splits worked. Dim is the easiest way to do that, or you can just view the data frame that was created, because these are data frames. We'll view them in a second anyway. Training data. Alright, there's 20, that means 28 rows, 5 columns. Testing data, 19 rows, 5 columns. Two things here, these obviously do add up to about 48, which is the 47, which is the number of rows in the original. In terms of whether the split worked, the easiest way to check that would be take that number of rows, which is 47, shown here, and do a quick calculation and use it like a calculator. Alright, so it's a little bit off, but that's probably because the number of rows in the original can't easily be divided by 0.7. Or multiplied by 0.7 divided by 7, or turned into 70%, 30% ratio. So we could definitely have deleted a row, you know, or a couple of rows in order to make that split work precisely. But this is a pretty good split. And the other thing I was going to say is these number of rows are pretty low, and you'd want to work with more data than this when you were making a model in the future. So let's just then make the model again. Let's make the full model again on only the training data frame. and compare it with the one we made for the full data frame from the full teengamb 2. Okay, so I will just again copy paste this and we'll call this one training model all. Switch this bit up, this is the only bit you need to change here, to training data. This response and predictors will stay the same here. Alright, quick check would be do we have the same results? Interestingly, in this case, with the fewer rows in the training data set, only income pounds per week turns out to be important. Sex does not. So that's obviously something that changed when we included fewer rows and we split the data. So it's something to keep thinking about how much data is needed for your question, how much data you should collect. So what I will do now is I'll only include this one, income pounds per week, in our new model. Notice the adjusted R squared is much lower now. So, sorry, we're going to do, training data again. We're going to do training model reduced. We're only going to include the single predictor that shows up as important here. Gambling expense PPW, squiggly line, income pounds per week. Okay, this model name goes here in the summary. A much lower adjusted R squared now, but this is only one that was seen as significant from the previous results. So now that we've made that new model, which only includes a single predictor, turned out to be the only important one in the training data, what we can do is we can use that model to predict the gambling. So use this model to predict the gambling expense PPW in the testing data. In the testing data. And that's where the predict function comes in. And this is when it gets really interesting. So let's start with a code for it. Okay, it's predict brackets, the name of the model first, training model reduced, this one here. Oh, by the way, you notice that when I start typing training model reduced, it comes up something like this little symbol here. That's often used for models, okay? And this symbol is used for data frames. So you see the difference in the symbols there, telling you what the objects are. Training model reduced, comma, testing data. Okay, should be enough. We'll try it. Alright, the results show up there. We don't want them here in the console. We want those predictions of gambling PPW and gambling expense PPW to be in a data frame. And you remember that to do that, you just create a new data frame here, predictions, back arrow, as.data.frame, and stick that whole prediction code in brackets. You can then view the predictions. And these are the predictions that it came up with for the given row numbers. If I'm to view the testing data set now, we can either do a kind of automatic comparison or a manual comparison to see how close the observations are to the predictions. View the testing data. And then for the purposes of not making this too long, probably leave it after that. So it's nice because you've got the row numbers that are shown there, and this was a random split. Okay, so 1, 3, 6, 8 from the original teengamb 2 are shown here in the testing, meaning that the other numbers that aren't shown here are only in the training. So it's what you call a random split. Row number 1, that's got a predicted value of gambling expense PPW according to the last model we made, 5.8596, which means about £6 spent per week. 1, okay, so this one was 0. So not so good. Let's find a better example. What did it say for 46? 46 was 3.39. No. 43 predicted 10.78. That one's pretty close, but that's showing you now what the R-squared was trying to tell you. This model was great. I hope to help you further on any specific models you want to make, any specific data frames. I would definitely do more with this data, look at the residuals more, some more tests of those, as well as ideally having more rows to work with, and then maybe transformations. If there are violations of a normality assumption, we would check definitely the distribution of the response column, and we could transform either the response column, the gambling PPW, or maybe even the predictor column, which is this one here, income pounds per week. Okay, log transformation is normally my first go-to, but there are other types of transformations. I hope that helped you, and it gives you an idea of how you can use the predict function, how you can use AICs and the importance of AICs. Lower is better, higher R-squared closer to 1 is better, as well as a brief reminder of the fact you want straight red lines, flat red lines close to 0 in some of these plots, which we don't necessarily have. And we would definitely want to reconsider if our model's great because of what we saw today. Next one would probably be within the next week or so, and might go back to more graph stuff just to mix it up a little bit and move to and from statistics and visualizations. Last thing is, I was going to make a video today about bibliometrics, which is a library that I can kind of just briefly show you this. It's a library that you can use to do bibliometric analysis, and it's really, really nice because it's an app. It links you to an internet website, okay? And I think this is a way forward with these kind of apps. Let's see. That link to HTML on the internet, where you can actually do stuff without necessarily having to use code. It's useful for beginners or people that are particularly code averse, but this is particularly cool because it can take citations for papers, okay, from a bibtex or a text document, and make all these kind of amazing graphs about what words are found in the papers, how a theme in a research subject or discipline has changed over time. And it's a pretty interactive website, to be honest. So there's a few different things I do like this nowadays. I wasn't sure about doing it though, because I would have to get the paper's citation text file from a repository, a database of papers, which, like, for example, would be, let's see, it would be like Web of Science or Scopus or Science Direct, or let's see what the other one is, PubMed. And then my video would generally involve going onto that website and showing you their website, and I don't know if I'm allowed to do that, you know, for copyright. So if you want help with that, message me privately. See you next time. Have a good week.